Constructing a two-column proof, example 4. So before we get into our angle relationships, we're first going to start with an algebraic proof, and we're going to look at how these are set up. For a two-column proof, first of all, we have two columns. We're going to write our work over here on the left, and we're going to put our reasons over here on the right. When you start with a proof, we're always given some piece of information, and then we have to prove another piece of information. So step 1 is always going to be what you're given. So on the work side, I'm just going to write 10 equals 1/2 x minus 5. And my reason for that is it was given. That's the given. Now, when you do a proof, everything has to be numbered and everything has to go just one step at a time, and do not show your work in the proof. So what I mean by that is if I'm looking at this equation, the next step I'm thinking is I would want to add 5 to both sides of this equation. So if you need to actually show plus 5, go over here on the left-hand side. And then we're going to go, okay, well, I'm going to add 5, I'm going to add 5, and if I add 5, that's going to get me 15 equals 1/2 x. So then I come back over to my proof, and my next step would be 15 equals 1/2 x. And that was because I added 5 to both sides of the equation. So step 2 reason would be the addition property of equality, which I usually get lazy and abbreviate. Then I'm going to come back over to my work and I'm going to say, okay, well, I have to get rid of 1/2. So I'm going to multiply both sides by 2, which is going to get me 30 equals x. So then step 3, I'm going to write 30 equals x. And the reason was because I multiplied both sides of the equation by 2, so that is the multiplication property of equality. Now, if I look very closely at what I'm supposed to prove and what I actually have, do you notice it's backwards? So we actually have to take one more step here, and I'm going to flip it. Now, when you flip something, just very simply, from x equals 5 to 5 equals x, or 30 equals x to x equals 30, and you just flip it, that is called the symmetric property. So think of something that is symmetrical. Usually you can like flip it over a line of symmetry. It's like a reflection on both sides, so it's symmetric. So these are the same, we just kind of flip them, so that's the symmetric property. And your proof is done.